All right, so let's go through these practice problems. We're going to use our calculator for these. This one says, consider the region bounded by y equals x squared and y equals cosine x. Find the volumes of the solids with the above region as a base, and the cross sections are perpendicular to the x-axis. So that's important because that tells us whether our equations are going top minus bottom, which they are if you're perpendicular to the x-axis, so everything's in terms of x, or if we're perpendicular to the y-axis, then you're going sideways, and everything would be in terms of y. And yeah, that's going to be the second round of problems. So let's graph this first. Clear out our old stuff. So we have x squared and cosine x. Make sure you're in radian mode. I'm just going to zoom 6 to start, see what happens. Yeah, so we're looking at this little region here. You can zoom in on it if you want. Oh, there we go. So because everything is going to be, all the shapes are going to be perpendicular to the x-axis, I just need the x points where they intersect. And this is symmetric, so if I just find one of them, I should be able to say what the other one is. So I'm going to sketch this region just here in general. So we have our x squared graph doing this. We have our cosine graph doing one of these. This is symmetric. So A's here and B's here. I just found B, 0.8 something. Let's see. 0.824133. You can find the other one. It might be off by a decimal place or two, but these are symmetric functions, right? X squared is an even function. Cosine x is an even function. They have y-axis symmetry. So I'm just going to say A is the negative version of this. Save myself a little bit of time on my calculator. All right, so what is the first one? So we're going to fill this region with squares. So it is a good idea to sketch it, whether you sketch the whole thing or not. You're just saying, okay, the side of a square is going to stretch from the top to the bottom, and we've got some square like this. That's usually what I draw for myself. Remember, this one is cosine on top, and x squared is the one on bottom. So the area of a square in general is the side length squared. So the side length here is cosine x minus x squared, and then we're going to square that quantity. And remember, the bounds are a to b. So our volume, it doesn't involve pi. We're not rotating anything. We're filling it with shapes. So this should be the integral from a to b of cosine x minus x squared, the quantity squared, dx. Now on this one, because I'm going to keep using the same a and b values, I'm going to store these. I did this in the last video on the first AP packet, but if you didn't see that, you can type in the bounds here, negative 0.824133, and you can store that, STO with an arrow is store, as one of the letters. So I want to store it as A, so alpha math. And now when I type in A on my home screen, the calculator knows it's that number. And then I'm going to do the same thing to store B. So this, store that as B. This is just a convenience thing. You don't have to do this. You could keep typing it out. You really should use the full decimals, though. If you've gotten in the habit of rounding these to 3, that might be okay. Sometimes you might get the same answer to 3 places, but you might be a little bit off, and you don't want to lose the point just because you were kind of lazy about the decimal. All right, so that means that I can go math 9 alpha A to alpha B. So those are the 2 decimals. And then it was parentheses cosine x minus x squared, parentheses squared. So this first volume is 0.874. So that's our first one. All right, the next thing is the same space, but now you're going to fill it with rectangles with a height of 3. So if you have, now you don't have to sketch this every single time if you don't want to. The area, if we have a rectangle with a height of 3, its base is going to be the top minus bottom still. So its base is going to be, I'm just going to say base here. In general, that area is 3 times whatever the base is. So for us, that's going to be 3 times the top minus the bottom. So let's just go ahead and set this up. It would be the integral from a to b of 3 times cosine x minus x squared. That one's not squared because it's just 3 times the base for the area of that rectangle. All right, so now I can just recall my last line, delete some stuff in here, or I guess I could. It's probably just as fast to retype the integral, but whatever. I'm getting rid of all of this. Okay, so this is 3 times cosine x minus x squared. Dx is already in there. 3.284. Now for part C, it says rectangles with heights that are 3 times the base. So now you have this rectangle where you've got the base, and then the height is not just 3, it's 3 times the base. So what is that area going to be? It's going to be 3 times the base, or 3 times the base squared. All right, so our volume will go the integral from a to b, and then it'll be 3 times, same thing, but put it squared. Because the base, again, if you want to draw this, the base is like here, and then we have this rectangle. All right, so that's nice. I'm just going to call up my last line here. I need to insert a parentheses in front of the 3. Oh, wait, not in front of the 3, sorry. No, wait, what am I saying? I don't need to I have parentheses around this expression already, so all I need to insert is a squared. Right there. 3 times cosine x minus x squared, the quantity squared. 2.623. Seems weird that squaring it would give you a smaller area or a smaller volume, but remember, we're working in a space where the x coordinates are decimals. So yeah, like 1/2 squared is smaller than 1/2, right? It's kind of that idea. Okay, what about semicircles? So you've got a semicircle. Again, the base is, or the diameter of the semicircle is in the circle. So this is diameter. And remember, that's equal to, the radius is half the diameter. So when we say, okay, a semicircle is 1/2 pi r squared. Well, remember, our diameter is cosine x minus x squared. So we're going to have, I'm going to make 1/2 pi over 2. We're going to have cosine x minus x squared, cut that in half to get the radius, and then we have to square the radius. So we did this in our notes. When you square this denominator, you get 4. 4 times 2 is going to be pi over 8, and then it'll be times cosine x minus x squared, parentheses squared. So the volume is the integral from a to b, pi over 8, which, yes, you could be pulling these constants out in front. It's all calculators, so it doesn't matter. Cosine x minus x squared, quantity squared, dx. Please remember to write the dx. We kind of lost our way a little bit on the worksheet that you turned in. It's easy to overlook as you're doing all of these, but we got to keep that as part of our answer so we get credit for our integrand, I should say. Okay, pi over 8 times cosine x minus x squared, parentheses, square that, dx, 0.343. All right. Equilateral triangles. So we talked about equilateral triangles in our notes previously. So remember the area of an equilateral triangle. If you want the proof for this, you can go back to our notes where we had. I'm going to remind you of where we did this. Wait, where did we do this? Did we do this? Oh, here it is. Okay. It's radical 3 over 4 times s squared. Oh, and I don't even have the proof for it here. I swear we did it in our notes. So this is like splitting up a 30, 60, 90 triangle and figuring out the sides. In interest of our video, I'm going to go a bit faster. So Radical 3 over 4 times side squared. The side in question is the base. So the area is radical 3 over 4 times side squared. The side is our cosine x minus x squared. So this volume is the integral from a to b of radical 3 over 4 times cosine x minus x squared, quantity squared, dx. All I want to change about this is that it's radical 3, and that's over 4. Otherwise, it is side squared. So 0.379. Okay, now we're looking at a different problem. So this says consider the region bounded by y equals ln x and y equals 1/2 x squared minus 2. Find the volumes of solids with the above region as a base and cross sections perpendicular to the y-axis. So let's sketch this graph first. See what we're working with here. So the first equation was ln x. The second one was 1/2 x squared minus 2. I'm just going to zoom 6. So we're looking at this region here. You can zoom it in if you'd like to. All right, so we need these points of intersection. Let me sketch this first. Always a good idea to have the sketch on your paper. So something like this. And now we're going perpendicular to the y-axis. So that means the shapes are going to be like something like this, right? So that means that everything needs to be right minus left. And that means that you need, for your intersection points, you need the y values. Everything's going to be in terms of y. So let's see where these intersect. There we go. Got to move my arrow so I'm actually on the curve somewhere. Enter, enter, enter. So the first one is negative 1.99067. And I'm going to use this for all of these. So let's go ahead and store these again. So A is the lower one, negative 1.99067. And B is the upper value. So get your cursor closer to that side. 0.split this here. 0.8745157. All right, and then we also remember, because we're doing right minus left, we need to rewrite these equations so that they're solved for x. So if you want to solve y equals ln x for x, you base e both sides. So e to the y equals x. So that's the one on the left. And then this one, this parabola, is the one on the right. So you would add 2. And then you would multiply by 2 to get rid of the 1/2. So 2y plus 4 would equal x squared. Square root both sides. There's technically a plus or minus in there, except all of these x values on this curve are positive. So it's the positive square root of 2y plus 4 equals x. Okay, so we have all of that organized. So this is A, this is B. So squares. What's the area of a square? It's side squared. The square, right minus left, is going to be the square root function minus the e function. So our volume, excuse me, should go from the integral from a to b of square root of 2y plus 4 minus e to the y squared dy. Okay, so I need to store new a and b values. So let's type these out first. Negative 1.99067, store alpha A. And 0.8745157, store alpha B. So now math 9, alpha A to alpha B. And then this is, what was I doing? This is parentheses, square root of 2x plus 4. Whoa, what? Why Where did that I come from? Second, I must have hit alpha. Second square root. What? Second square root. There we go. 2x plus 4 minus e to the x. Parentheses. Squared. dx. I think I'm missing a parentheses. That might give me a syntax error. Having more trouble with this one. Insert parentheses. Okay, I think I'm good. Enter. 2.165. On to the next. Rectangles with a height of 2. The height is 2, and then you've got this base. The area is 2 times the base. The base is right minus left. So volume will be the integral from a to b of the square root of 2y plus 4 minus e to the y, no squared, dy. That means I should just be able to take the squared off of here. It doesn't matter that you have this extra set of parentheses. I think that's okay. So 2.333. All right. Rectangles with a height that is twice the base, which is in the region. So now we have this base, and we have this 2 times the base for the height. So when you find the area, base times height will be 2 times base squared. So that volume is the integral from a to b of 2 times square root of 2y plus 4 minus e to the y quantity squared dy. Let's see, is that just going to be, we found this area here, so shouldn't that just be double that one? We can type it in to find out if we want. We're just doing this and putting a 2 out in front, so yeah, it should just be double our first area, because you could have pulled the 2 out in front of your integral. Yeah, 2.16 is now 4.32. That seems right. So this is actually going to be 4.330. I don't like to think too much about what I think these areas and our volumes, should be, because especially when decimals are involved, when you're between 0 and 1, it can get confusing about like what should be happening. I often find that I'm wrong about what I think it should be, bigger, smaller, whatever. So just, you don't want to talk yourself in circles. Just go ahead and go through the mechanics of everything to begin with. Semicircle is 1/2 pi r squared. Remember that it's the diameter that is your right minus left. So we need to do half of the diameter, half of the right minus left. So that's going to give me pi over 2 times, I'm just going to write this out, right minus left over 2, that's the radius, squared. So this is the integral from a to b. There's going to be a pi over 8 out here. And then right minus left squared again is square root of 2y plus 4 minus e to the y quantity squared dy. Let's see. That's just this thing, right? And I just need a pi over 8 instead of a 2. Copy and paste, you need to be careful with that. So if you're kind of like, if you think you might make a mistake, as I'm sitting here making mistakes, if you think you might make a mistake and paste the wrong thing, it's not that hard to retype this. It's just, I don't know. I kind of like using it when I can. So pi over 8 times this thing squared is what I said it was going to be. So that's 0.850. Okay, and finally, equilateral triangles. So again, earlier in our notes, maybe it's in here where I did the little proof. Oh, there it was. Yeah, you can go through all this fun stuff if you forget what the formula is. You split an equilateral triangle in half, you get a 30, 60, 90. You go from there. But it comes out to, I would just memorize it, comes out to radical 3 over 4 times side squared. Side is your right minus left. So this volume should be the integral from a to b of radical 3 over 4 times square root of 2y plus 4 minus e to the y squared dy. So let me just call up that last line and change the pi over 8, just like I did on the previous page, to a radical 3 over 4. 0.937. All right, so hopefully this gives you an abundance of practice. I really can't think of any other shapes that we tend to fill our spaces with, any other cross sections. So if you are good on these, then you should be in pretty good shape. Next thing we do is practice some AP problems.